Good evening, everyone. Welcome to week 9 problem solving session. Today I'll be discussing questions related to week 9 lecture materials and week 9 assignment solution. So let's start. The first question is the correct statement, the correct thermal stability order of the hydrate of group 15 element is. Option A is NH3 greater than pH3 greater than ASH3 greater than SBH3. Option B is NH3 greater than ASH3 greater than pH3 greater than SBH3. Option C is NH3 greater than SBH3 greater than pH3 greater than ASH3. And option D is pH3 greater than ASH3 greater than NH3 greater than SBH3. So in group 15, the order of elements is nitrogen, phosphorus, uh, arsenic, antimony, and bismuth. So when we move down the group, electronegativity of elements decreases. So in hydrates, H is in H minus. So when it move down the group, uh, the bond strength of element and the hydrate decreases down the group. So the bond strength decreases down the group. So hydrate of N will be more stable than phosphorus, than arsenic, than antimony, than bismuth. So the correct order is option A, NH3 greater than, pH3 greater than, ASH3 greater than, SPH3. And because the reduction stability down the group, the ability of the hydrate to reduce increases down the group. The H can be removed as H minus from the hydrates while we move down the group. The next question is the incorrect statement of phosphine. pH3 is, option A is pH3 is more toxic than NH3. B is like NH3. Liquid phosphine is associated with H bonding. Option C is alkyl or aryl phosphines are more stable than pH3. And option D is phosphine can be synthesized by hydrolysis of Ca3P2. Let's go through each statement. First one is pH3 is more toxic than NH3. So this statement is correct because pH3 is less stable than NH3. We have seen it in the previous question. So stability of pH3 is low, so the dissociation ability of pH3 is higher, so it's more toxic than NH3. So this statement is correct. And next one is like NH3, liquid phosphine is associated with H bonding. The statement is wrong because in NH3 the nitrogen is highly electronegative, so the NH bond will be polarized, hydrogen will be delta plus and nitrogen will be delta minus, so their bond is polar, so hence there will be interaction of nearby H like this. So that's why there is hydrogen bonding in ammonia. And in phosphines, P, H, S, and H, the phosphorus is less electronegative compared to nitrogen. So the polar ability to polarize pH bond is less compared to N. So the hydrogen bonding is not possible in liquid phosphine. The next option is alkyl or aryl phosphines are more stable than pH3. This statement is correct, and alkyl and aryl phosphines are used as strong stabilizing ligands in complexes. And option D is uh, phosphine can be synthesized by hydrolysis of Ca3P2. So this statement is correct. Ca3P2 plus 6H2O will give 2pH3 and 3CaOH twice. And this is one of the method to produce pH3, and other methods to produce pH3 are pH4i reacted with potassium hydroxide. It will give pH3 plus Ki plus water. And if we use PCl3 and reduce with lithium aluminum hydride in Et2O, it will give pH3. So the answer is option B, which is the incorrect statement. The next question is a side reaction of NH2Cl and N2H4 in Raschig process give. Option A is N2 and HCl. Option B is NH3 and N2H4 or HCl. Option C is N2 and NH4Cl. And option D is no reaction. So Raschig process is used to synthesize hydrazine, which is N2H4, and it's the synthesis process is NH aqueous ammonia and NaOCl reacted to give NH2Cl and sodium hydroxide, and this NH2Cl is reacted with ammonia. It gives N2H4 and ammonium chloride. So the side reaction is 2NH2Cl plus N2H4 react to give N2 and ammonium chloride. So the formed hydrazine and NH2Cl react to give N2 gas and ammonium chloride. So the answer is option C, N2N NH4Cl. The next question is the correct statement about hydroxylic acid HN3 is first statement is aqueous solution of HN3 is weak acid of pKa 4.75. Second option is azide ion is isoelectronic with CO. And third one is hydroxylic acid can be synthesized by NaN3 and H2SO4. So let's go through each statement. The first one is aqueous solution of HN3 is a weak acid of pKa 4.75. So the statement is correct. When HN3 is dissolved in water, it forms H3O plus and N3 minus with pKa equal to 4.75. So first statement is correct. And the second one is azide ion is isoelectronic with CO. So azide ion is N3 minus, which we can rewrite as N2 plus N minus. So in N2 there are 14 electrons, and in N minus there will be 8 electrons. So total will be 22 electrons. In CO, carbon and oxygen will be having, carbon has 6 electrons and oxygen has 8 electrons. So it's total of 14 electrons. So they are not isoelectrons, so the statement is incorrect. But azide ion is isoelectronic with CO2, C plus O2. Carbon has 6 and O2 has 8 plus 8, which is 16. So total 22 electrons. So these two are isoelectronic. And third statement is hydroxylic acid can be synthesized by NaN3 and H2SO4. The statement is correct. If we use 2NaN3 plus H2SO4, it will give 2HN3 plus Na2SO4. So the statement is correct. So option B is the correct answer. The next question is treatment of NO2 with H2O gives option A HNO2, option B HNO2 and HNO3, option C is HNO3, and option D is H2NO3. So NO2 exists as dimer N2O4, and it's a very strong oxidizing agent. When NO2 react with water, it will be like in the order 2NO2 plus H2O. It will form both HNO2 and HNO3. And other oxides of nitrogen uh, other oxides of nitrogen are uh, N2O and N2O3. So these react with water to form H2N2O2, and N2O3 react with H2O to give 2HNO2. So the correct answer is HNO2 and HNO3 are produced when NO2 is reacted with H2O. The next question is nitric acid on heating above 273 Kelvin turns yellow in color due to the formation of option A is H3O plus and NO3 minus, option B is NO2, option C is NO, and option D is N2O4. So the yellow color is due to decomposition of HNO3 which forms NO2. So the reaction will be 4HNO3 decomposing to give 4NO2 plus 2H2O plus NO2. So HNO3 is a very useful compound used in production of fertilizers in the formation of ammonium nitrate, and it is synthesized by Haber-Bosch process. So in Haber-Bosch process, start with 2NO, react oxidize to form 2NO2, and 2NO2 will be forming N2O4, and this N2O4 is reacted with water, giving HNO2 and HNO3, and 2 HNO2 are converted to NO and NO2 plus water, and this NO2 is reacted with water to give HNO3 and NO. So 3 NO2 plus H2O will form 2 HNO3 plus NO. So this is the Haber-Bosch process. So the answer for the question is nitric acid on heating above 273 Kelvin turns yellow in color due to the formation of NO2. So option B is the answer. Next question is the option showing the correct statements about nitric acid are: first statement is dilute HNO3 on treatment with copper, liberate NO. Second one is concentrated HNO3 on treatment with copper, liberate NO2. Third one is treatment of HNO3 and HCl in 1:4 ratios with gold, liberate NO2. And last option is very dilute HNO3 on treatment with magnesium, liberate NO. So let's go through each statement. First one is dilute HNO3 on treatment with copper, liberate NO. So the statement is correct. So the reaction is 3 copper plus 8 HNO3 in this is diluted. It will give 3 CuNO3 twice plus 4 H2O plus 2 NO. So it produces NO gas. So the statement is correct. And second one is concentrated HNO3 on treatment with copper, liberate NO2. So 3 Cu. So copper plus 4 HNO3, which is concentrated, will give copper nitrate plus water plus 2 NO2. So it produces NO2 gas. So the given statement is liberates NO2, which is correct. And third one is treatment of HNO3 and HCl in 1:4 ratio with gold, liberate and O2. So treatment of HNO3 and HCl in 1:4 ratio liberates NO gas, not NO2. And this 1:4 ratio of HNO3 and HCl is called as aqua regia. So gold in HNO3 plus 4 HCl. So it's 1:4. produces NO plus HAuCl4 times plus 2H2. So the produced gas is NO, not NO2. So the statement is incorrect. And fourth one is very dilute HNO3 on treatment with magnesium liberate NO. So the statement is incorrect because magnesium, manganese and zinc when treated with HNO3 will produce H2 gas. So this statement is wrong. So the correct answer is option D. The first statement and second statement are the correct ones. The next question is the reaction of copper with concentrated HNO3 leads to the formation of option A is NO, option B is N2O5, option C is N2O, and option D is NO2. So we have already discussed in previous question. So copper with concentrated HNO3 will give NO2, and with dilute HNO3 will give NO3. So with concentrated nitric acid, reaction of copper will give NO2 gas. So option D is the answer. Next question is H3PO4 on treatment with POCl3 gives option A H4P2O6, option B H3P2O5, option C H5P3O10, and option D H4P2O7. So this is a method for synthesis of polyphosphates. So 5H3PO4 reacting with POCl3, it will give 3H4P2O7 and 3HCl. So the answer is option D, and dehydrogenation of H3PO4 also will give H4P2O7. So the reaction is so the at 510 Kelvin, water will be removed. So water molecule will be removed like this. So it will form H4P2O7, which has the structure PO. P linkage will be formed, and double bond O, OH, OH, and double bond O, OH, and OH. So this will be the structure for P2O7 and with 4 H plus. This is a tetrabasic acid, and if we heat H4P2O7, it will give H5P3O10. So further heating from here along with H3PO4 will give H5P3O10 plus H4. And H4P2O6 is also available, which is hypophosphoric acid, and it's synthesized from red phosphorus. Next question is the reaction of PCl5 with ammonium chloride at 130 degrees Celsius lead to the formation of option A, Cl2P double bond N 3 times, option B Cl2PN 4 times, option C is Cl2PN 2 times, and option D both A and B. So the reaction of PCl5 with NH4Cl at 130 degrees Celsius is actually synthesis route for polyphosphosines. So polyphosphosines are in the form of Cl2P double bond N and N. So it will be N can be 3, 4 and above. So if we treat PCl5 in NH4Cl at 130 degrees Celsius in the presence of tetrachloroethane, which is Cl2, 2CH2, Cl2, will give Cl2P double bond N times, where N equal to 3, 4. So at this particular reaction condition, it will give polyphosphine with N equal to 3 and 4 only. So the answer is option A and B, which is Cl2Pn thrice and Cl2Pn 4 times. And if we use instead of NH4Ca, if we use NSIMe3 thrice, it will again give Cl2Pn 3 times, which is and if we heat this one, it will form polyphosphosine. And the cyclic trimer is synthesized by uh, a longer route. So it's first start with NH4 plus ion in NH4Cl reacting with PCl6 minus. So the reaction start with 3 PCl5 and NH4Cl reacting to form Cl3P bond N bond P Cl3 plus and PCl6 minus, and this PCl6 minus will react with NH4 plus in NH4Cl. So we have two different species here. So we can denote this as 1 and this as 2. So 1 and 2 react. Cl3P and 1 PCl3 plus and Cl3P 1 NH. They react to give Cl3P 1 N P 1 N 1 P Cl3. So the HCl is removed from one hydrogen from this nitrogen, and one Cl is removed. So so it will be removed as HCl, and when we add uh, one more Cl3P1NH, again one HCl is removed, and it will give Cl3P1N PCl2 1N PCl2 and PCl3 plus. So there should be PCl2 here, because there was 3 chlorine here, so 1 Cl is removed, then 2 Cl will be remaining here, so that's PCl2 here. So again when we add one more Cl3PNH, this H will be removed with one of the chlorine, so HCl is removed, so the Cl3 becomes Cl2, and this Cl3Pn will be forming a bond here, and from here PCl4 will be removed, which will form our cyclic phosphocene, which is P. And the phosphocenes are isoelectronic with silicates. So the one group, that is Cl2P bond N thrice, it's isoelectronic with Me2SiO group. So this is the synthetic route for cycle trimer of phosphocene. The next question is thermal disproportionate of phosphinic acid H3PO2 gives. Option A is PH3H3PO2. Option B is H4P2O6 and PH3. Option C is PH3 and H3PO4, and option D is PH3 and H4P2O7. So phosphinic acid is H3PO2, 3H3PO2. On heating, it will be giving PH3 and H3PO3, which is phosphonic acid. And another one is 2H3PO2 giving PH3 plus H3PO4, which is phosphoric acid. So on decomposition of H3PO2 will give both H3PO3 and H3PO4 along with phosphine. So we are given option C with S3PO4. S3PO3 is not given, so we can say the answer is option C. And there is S3PO3. So it upon decomposition it gives phosphoric acid. So for S3PO3 on decomposition will give PH3 and 3H3 PO4. The next question is the most unstable hydride is option A NH3, option B PH3, option C is BAH3, and option D is ASH3. So we have already discussed similar question in group 15 from top to bottom. Electronegativity decreases, element to hydrogen bond strength decreases, so stability of hydride decreases down the group. So nitrogen, phosphorus, arsenic, antimony, and bismuth. So this is the order in the periodic table in nitrogen group. So among these, the lowest that is least stable will be hydride of bismuth. So the option C is the answer. Next question is species that doesn't contain an N bond is option A is N2O, option B is N2O3, option C is N2O5, and option D is N2O4. So let's write down structure for each compound. In N2O, the structure is N bond O, and in N2O3, and N2O5 is N2O5, and last one is N2O4. So from all four, we can see that in N2 there is an N bond, in N2O3 there is an N bond, in N2O5 there is an O bond, no direct NN bond is present, and in N2O4 there is one NN bond. So the correct answer is option C, N2O5. The next question is on heating ammonium nitrate NH4NO3 at 400 to 520 Kelvin gives option A is N2O and 2H2O, option B is NH3 and HNO3, option C is N2H4 and O2, and option D is HN3 and H2O. So on heating at the given temperature NH4NO3 at 400 to 520 Kelvin decomposes to give N2O and water. This is one of the synthetic route for N2O, and other routes are reaction of NH2OH with HNO2. It will give N2O and water. So the answer for this question is N2O and water. So option A is the answer. The next question is the incorrect statement of hyponitrous acid H2N2O2 is option A, it is potentially explosive. Option B, decomposes spontaneously to give N2O and H2O. Option C is its cis configuration is kinetically more stable. And option D is it's a weak acid. So the first statement is correct because the material is highly unstable, it will decompose at low temperatures. And option B is decomposes spontaneously to give N2O and H2O. The statement is correct. H2 N2 O2 will decompose to give H2O plus N2O. And its cis configuration is kinetically more stable, which is incorrect because kinetically stable structure will be trans structure. So there will be minimum repulsion among the lone pairs on nitrogen. And fourth one is it is a weak acid, which is correct. So the incorrect statement is option C. Cis configuration is kinetically more stable. The correct version will be the trans configuration is more kinetically stable. And next question is P4 external hydrolysis lead to the formation of option A H3PO4 and H2S, option B H4P2O6 and SO2, option C H3PO3 and H2S, and option D H3PO2 and SO2. So P4O10 reacting with water, it will form phosphoric acid, which is 4H3PO4 and then H2S. So option A is the answer, and P4 ester is synthesized from white phosphorus. So white phosphorus in presence of sulfur at greater than 570 degree 570 Kelvin, it will form P4 ester, and its structure is similar to uh, P4O10. So we can see that in P4O10 will be so this is P4O10. So the structure is similar for P4 ester as well. But when we see the lesser number of sulfur, P4S9, they remove one, here one sulfide, that double bond S is removed, and in P4S7, two P double bond S is removed, and one PP bond is present instead of that one PSP bond. That S is also removed from P4S10 to form P4S7, but in P4O7 the structure is P double bond O. In P4O n times, first they start with bridging oxygens. So all so this is P4O6, but we can see here in P4S6 that POP linkage is missing. Instead there is P double bond S. But in P4S6 only POP bridging bonds are present. No P double bond O is present. In P4S7 they have added one double bond S to next phosphorus, and again there is no bridging sulfur between one P one pp bond is present, no psb bond is present there. So in P4O7, so in here one double bond O is present, and all are POP linkages. So in P4S7, one PSP is missing. Instead, P double bond S, two of them are present. Next question is gold. React with aqua regia to give option A AuCl3, NO2 and H2O. Option B H AuCl4, NO2 and H2O. Option C AuCl3, NO and H2O. And option D HAuCl4, NO and H2O. So aqua regia is HNO3 and HCl in 1:4 ratio. So it's AU plus HNO3 plus 4 HCl will be NO plus HAU Cl4 plus 2H2. So the correct answer is option D, HAuCl4, NO and H2O will be formed. The next question is the reaction of P4O6 with one equivalent of Me2S BH3 followed by slow crystallization from toluene solution at 244 Kelvin gives. Option A is P4O6.BH3. Option B is P16O24 BH3 4 times, and option C is P8O12 BH3 2 times, and option D is P12O18 BH3 3 times. So this reaction will give P4O6 plus Me2 S dot BH3. So the reaction is supposed to give P8O12 BH3 twice. So P4O6 is having this structure, and when it reacts with Me2S BH3, it forms P8O12 BH3 twice. So the structure is like this. So here what happened is one POP linkage is broken. Here also one POP linkage is broken. So initially this was a bond, and this one also. So two P4O6 units links by breaking one of their POP bond, and the BH3 in Me2S BH3 coordinated to phosphorus lone pairs. Next question is H3PO2 and H4P2O7 are respectively. Option A is tribasic and tetrabasic. Option B is dibasic and tribasic acids. Option C is monobasic and tetrabasic acid. And option D is tribasic and dibasic acid. So oxoacids of phosphorus are named monobasic, tribasic, tetrabasic, etc. depending on the number of OH group attached on phosphorus. The hydrogen on OH can be removed as H plus, while that on phosphorus do not dissociate to form H plus. So in H3PO2, the structure is form O, H, H, and OH. So the hydrogen on oxygen, it can be removed as H plus, and these hydrogen will not be dissociated. So only one hydrogen can be removed, so it's monobasic. In H4P2O7, the structure is P mono OH, OH, and P. So here 4 hydrogen are present on oxygen. So all these 4 of the hydrogen can be removed as H plus. So it is tetrabasic. So the answer is option C. H3PO2 is monobasic and H4P2O7 is tetrabasic. And other acids like H3PO2, it will be in, this is H3PO2, this is H4P2O7, and in H3PO4, it is 0.0 H. So 3 hydrogen on oxygen are present. H3PO. So 3 of the hydrogen can be removed as H plus. So it's tribasic. And in H3PO3, the structure is P bond, one hydrogen directly bonded to phosphorus, then one OH and another OH. So 2 hydrogen can be removed as H plus, and this H will not be dissociated, so it's dibasic. The next question is P31 NMR spectra of PF5 at room temperature show n number of lines. Option A is 5, option B is 6, option C is 12, and option D is 8. So due to Berry pseudo rotation, the axial and equatorial fluorine are very hard to distinguish and they appear to be same. So here the blue ones are axial and red ones are in equatorial. So at very low temperature, the uh, fluorines present on equatorial will move towards axial, and on the axial will move towards to equatorial. So it will finally form this TVP structure again, but the axial and equatorial portions are interchanged. So it will be really hard to distinguish between axial and equatorial portions. So there are 5 PF bonds, and number of lines are uh, calculated by the equation 2ni plus 1, and I for nuclear spin of P31, it is half. So here n equal to 5, 5 PF bonds are present. I of P equal to 1 by 2. So the splitting number is 2ni plus 1, which is 2 into n equal to 5, and I equal to 1 by 2 plus 1, which is equal to 6. So room temperature shows 6 lines. So the answer is option D, 6. So that's all for today. If you have any doubt, you can ask now. We'll see you next week. Thank you. Yeah, uh, nuclear spin. You are asking about nuclear spin? Yeah. For each nuclear spin is um, It's denoted for each element nuclear spin is present. So it's the total nuclear spin. In nucleus, there will be spin like this, right? So some of them will be in opposite direction. If it's there, they will be cancelled. So if it's opposite directions are not present and some are present like this, so this will be present as half and other will be cancelled. Okay, so in phosphorus, the spin is like this. So if there is five uh, nucleons and some of them are in opposite and only one is present as like this, it will be total of half. So in phosphorus, it remains as half. Do you have any other doubt? Hello? Yeah. Mm. This question, how is the uh, coordinated complex? I don't think so. Mm. Uh, are you asking if it's a complex? Can you write the question in the chat box? Yeah, CuNO3 twice in the complex form. Mm. Here copper is in 2 plus state and NO3 will be in minus 1. So 2 NO3 is present, so the charge is neutral. Because of concentration only. Yeah. Thank you.